First of all, we should talk about the plan because this is a big week. Number one, your 6.6 is due tomorrow. There's an after-school environmental film tonight and tomorrow night. It's kind of grim about coal mining in Appalachia. Interesting politics.
You switched it to Monday, Tuesday?
No, I'm sorry. I meant Tuesday and Wednesday. Thanks. There was people talking when I was saying it. Tuesday and Wednesday. Cass, I think this is yours.
No.
Are you sure?
Yeah. Unless that's from like 5 weeks ago.
No.
Okay.
I'm gonna guess it's an hour and a half. It's pretty standard, like widely distributed. So yeah, Tuesday and Wednesday. For your solar house resubmissions, option number 1, after school today. Option number 2, after school tomorrow. Option number 3, seminar Wednesday and seminar Thursday. Yeah.
After school, even after 5th?
After 5th, yeah, my after school, okay. Which is your period 6. At the start of your period, yeah, meet that. You know that the test is this Friday. Yes?
Wait, actually?
Yes?
Do you do?
No? And so, today we finished 6.4, the renewables. Tuesday and Wednesday, we do nuclear, which is kind of big chunks. I hope you're planning to attend Tuesday and Wednesday. Be careful if something comes up that forces you to miss those. You can attend any of my other periods. On Wednesday, we'll also skim the reading packet and movie questions and do the stars for the test, which is this Friday. I've warned you since before this unit started, but it's a long 6-week unit with a lot of understandable distractions in the middle. There are 4 chapters, the basic energy stuff that happened way back here, the fossil fuel stuff, which happened like 2 weeks later, the renewables that we're getting to the end of now, and then the nuclear that we're going to do in the next couple of days. It's a lot of stuff to keep together. Don't let this one sneak up on you. It's the first of the 2nd semester. It will launch your next grade. Focus, invest. It's a big week. I understand that. If it makes you feel any better, I have a stressful week too for totally different reasons. Today you're going to need really good notes. You don't have this yet. You may want to leave yourself some space and draw those in. I know. I did it on purpose. That was an accident.
You just hung up. My friend's Christmas present that I never got. Makeup.
Girl stuff.
Yeah, I know.
I fixed my laser pointer, so I'm really happy.
Yeah, it works really well.
It works really well.
Yeah. Is that like, can I sue you for that?
I mean,
Let's
you,
find out.
A, you'd be wasting your time. All you get is all my debt. B,
I can get your boat.
this is America. It's not mine. America, you can sue me for anything you want. C, I'm not harming you. It's the green ones that make you blind.
My eye still really hurts.
Say what?
Purple.
Your eye does not hurt from this.
This one, yeah.
Oh, Claire.
Very sensitive
Claire.
eyes. I have very sensitive eyes.
I'm gonna
Weird, fucking weird. So.
You have classes.
Okay.
Okay. Oh my god, I'm blind! Just kidding. Alright. We have discussed, you wouldn't want to leave it like focused for a long time on your eye. That could be bad. We have discussed tidal barrage. Now let's look at biomass and geothermal. You might remember biomass from the, what's it called? From the micropower slideshow at the beginning of this unit. Biomass, like you can just make heat in your home by burning like chunks of wood or whatever. Remember that all biomass is current carbon, like short cycle, like our biosphere is already juggling this amount of carbon. So it's not like the old stuff that went into the rock that you really got to worry about. It's not the carbon that's left our system for hundreds of millions of years and has been brought back. Unlike fossil fuels, any carbon from biomass was in play just recently. So putting it back into the atmosphere doesn't really affect the CO2 volume overall in the atmosphere. Biomass is short cycle carbon. So you can, number one, burn it directly like wood chips or agricultural waste. And I gotta say an unpopular thing, but I'm gonna stick to my guns on this one. For most people, I've heard somewhere, and I actually kind of believe this, that it is more sustainable to burn your paper as an energy source than it is to recycle it. Don't quote me on that, but do consider that option. Stay open to somebody convincing you of that at a later time. I think that the smart move with paper is to burn it, not recycle it. Al Gore wrote a famous book about the environment a long time ago, and he made that claim, and a bunch of hippies jumped down his throat, and then a bunch of other hippies proved him right. Anyway, number one, burn it. Number two, if you remember from the car lot of the future, you can feed carbon to yeast and they will ferment it into ethanol. You might remember from the car lot of the future that growing corn to make ethanol, the way that we make most of our alcohol in the US today, or ethanol in the US today, that's pretty wasteful. We end up making more carbon when we grow corn than we get when we ferment it into ethanol. So this corn is not the right biofuel to ferment. But switchgrass or agricultural waste to like cutting edge technologies, I think that would be the right choice. Those are smiley faces for making ethanol. And number three, I think I've told you before that your farts actually are flammable, and I hope you remember the secret ingredient that makes your farts flammable is methane from anaerobic decomposition. If you don't have it in your notes somewhere else, you got to make sure you write the stuff on paper somewhere, because you got to remember this. It's anaerobic, no oxygen around. That makes the methane. So at the personal level, anaerobic, like your intestines, makes methane. You can light the natural gas from your farts. As an organismal thing, that's true of all digestion. If there is anaerobic digestion in the gut of an animal, you'll get some amount of methane. Some animals who have really messy digestion, like cows, they produce a lot of methane. Have I told you before that the world's cows cost roughly the same global warming as the world's cars? Cow farts. All that methane is 10 times hotter than CO2, so they don't make the same volume of greenhouse gas as cars. Cows don't make the same amount of gas as cars. They do make about the same amount of global warming, but they've got a lot of methane. There's a lot of anaerobic digestion when you add up all those cows. Especially because we feed them such weird stuff. So like your farts, anaerobic decomposition makes CH4, methane, and pretty much anything with carbon will do that. So wastewater will do that, landfills will do that. Slaughterhouses make a ton of methane. And right now, all that trash is handled all willy-nilly. But if we collected all of the carbon-based trash into single digestion, that could make a lot of natural gas. That's a really cool set of alternatives for heating, for liquid fuels, and for gas fuels. You had a hand, Ryan?
Yeah, so when this unit talks about digestion, it's like having animals actually eat carbon and then use that methane, right? Or is it?
Well, I want to just clarify one little detail. If you count bacteria as animals, yes.
Okay.
So there's a reason why this gets confusing, so I want to clear it up. Watch me. Animals digest their food. That's digestion by animals. In our guts, we're not actually breaking those carbon bonds. There's bacteria that do that. So your digestion, like you, Ryan, your digestion depends on bacterial digestion. That bacterial digestion, if it's anaerobic, makes methane. And you can make a fake gut at the wastewater treatment plant or at the landfill or whatever. Yeah?
So you just capture the bacteria anaerobic.
So you just use all that?
You would just so you find a way to capture that, or like what would you do?
Well, now that you got natural gas, you could just run
Pipes
to a combustion chamber to a turbine to make electricity, natural gas power plant. Or you can send that off to houses and people can do all their home heating with that or whatever. It's the same methane.
Yeah.
Yes? No? Okay. Would anyone else like to talk to me about biomass? Period 3 has a slight head start on the other periods. I have the time if you have the questions. Remember, home heating, liquid fuels, natural gas. 3 types of biomass energy. Last of all, the geothermal. Raise your hand if you've been to Yellowstone and seen the geysers, the steam geysers. Raise your hand if you've been to Mammoth Lakes, California, and been to the hot tubs, the hot springs. Hot Creek, the Wild Willie's, Crab Cooker, Shepherd, Lone Tree. Raise your hand if you've been to the hot springs up above Montecito that are now probably not very accessible. Did anybody get in the water at the Montecito hot springs, the little tarp pit? It's kind of muddy and smells bad, but by the banana trees. Anybody been to the Little Caliente hot springs on the backside of East Camino Cielo? Those are pretty cool. My homie built those as a wedding party the day before his marriage. Anybody been to the hot springs up by Gaviota? By the wind caves in Gaviota? How do these work? Geysers in Yellowstone, hot springs everywhere. How do they work? Some places, the Earth's crust is very thin. There's magma near the surface. It's a thin spot in the crust. So in nature, please look up. Surface water in nature trickles through the crust, hits the roof of hell, and all of that damnation down there heats the water and it comes out hot. If you have a thin spot in the crust or a weakness in the crust, that water can trickle down until literally like the magma below your feet heats that water, and because it's heated, it rises and it expands and it starts to boil and bubble out. Sometimes it builds up back pressure of steam below cold water so that it just goes poof, and it makes explosions regularly like the geysers in Yellowstone. Sometimes that water goes in hot, gravity carries it somewhere where there's another weakness, and it rises having been heated. Those are hot springs. What if you could find those places and make artificial geysers? Like this. You inject cold water, break up the rock, like hydraulic fracturing. You break up the rock that's very, very hot. And so when you inject the cold water in, it goes through those cracks that are all broken up and heated, and then comes out of the ground heated for you. You add cold water, and check this out. The earth spits out steam for your turbine. This is kind of easy and straightforward as long as you've got the thin crust. You got to be able to reach the fire and brimstone. Yeah.
Sorry, that's in brimstone? How do you spell
Yeah, this is fire and brimstone, which is not actually science. That's a joke about the heat source. That should say magma. If you copy things word for word, you might end up with some pretty wacky stuff in your notes that won't work on the AP test. How many of you literally wrote fire and brimstone in your notes?
I would have if I could have read it.
Nice. All right. Wash my hands. Wash my hands. Ready? Divergent, convergent, transform. What is that? Tectonic plate boundaries. Please look up. Convergent, convergent. There's a little transform boundary called the San Andreas. Convergent underneath the Andes. Big convergent one here. Convergent in the middle of a continent right there. Mostly convergent boundary around the Ring of Fire. But what are these ones right here, those white ridges? What are those? Those are divergent. Anybody ever had a scab on a flexi spot and the scab would break open and juice would come out and make like a ridgeline in the middle of your scab? If you were ever a child, you probably experienced this. It's kind of fun. I don't know, anybody else love picking their scabs? I love picking my scabs. I have scabs 24/7. I have scabs right now. Love scabs. Anyway, watch this. Your scab breaks, the plasma flows out and kind of makes like a little ridge line. Then it breaks again, and more plasma piles up on that, and then makes another ridge line, and then it breaks, and you get like a little mid-Atlantic ridge on your elbow. Now, all of those are new tectonic plates. They're fresh. So they're thin, so water holds them down. They're almost entirely underwater, with one exception. Anybody know what that thing is? That's Iceland. Here's a wacky thought. Of all the nations on Earth, only Iceland has that breaking scab idea. Iceland is the only nation that has surfaced divergent boundary, meaning it's above sea level. As a matter of fact, if you look at a map of Iceland, it's like a mountain line down the exact middle of Iceland, the long way. Iceland's shaped like that, and all down the middle there's a mountain ridge. And that's a bunch of mountains that are spreading and growing. You can like hop up there, like every now and then they vibrate, and like there's a whole bunch of cracks because that's all fresh rock. So Iceland has a whole bunch of thin crust with a lot of cracks for the water to flow. I wonder what they could do with that.
Don't they already do geothermal energy?
They are the only country on Earth whose electricity grid is primarily and almost exclusively geothermal. They're carbon neutral.
I saw this thing in the National Geographic, and it was like this huge lake, and people were like playing in it, and it was like 40 degrees outside, but the lake was like 80.
Yes. Because Iceland has the most like, first of all, they have a ton of water because the snow, because it's like pretty close to the Arctic.
Just a little.
And then, with all that water, they also have all these like thin crust spots with hot water like you saw on National Geographic. So they're currently the only country who's entirely off fossil fuels, but they're also building the world's largest wire. Not longest, largest. Anybody know what they want to do with all of their geothermal electricity and giant extension cord? I wonder if there's any place nearby with a booming economy and lots of people who are environmentally conscious trying to get off fossil fuels. Europe? Yeah, not us. So check this out. Iceland has plans to become the Saudi Arabia of geothermal. They will probably be the world's largest energy exporter sometime in your lifetime. They'll be exporting straight up electricity, not stuff that you transform into electricity. And if they lose a little bit in the wire, who cares? They make it for free. And once they finish building this, they can basically just start cashing in forever. Checkmate Iceland. Holy crap, Savannah, what is that thing on your arm?
Brace.
That's a lot of brace. This thing's not really serious with your wrist, huh?
It's my elbow.
I thought it was your wrist. Let me see that. Let me see that brace. Oh.
It locks out, so I can't straighten it.
It what?
It locks out, so I can't straighten it.
Like mechanically, like if you go like this, you.
Yeah, I can't get it set.
You think if you hit somebody with that, it would
Oh
hurt?
yeah, my mom hit her head on the elbow.
That's pretty terminating. Got a weird dial on it?
Yeah, it's where you like control how far out it can
Oh, cool. My knee brace didn't have that. So that's like the maximum for it to
go. I can
flex?
only go to like here.
All right. Geothermal in Iceland. And we have just one thing left. With all of these ideas and all of these possibilities, why is almost every single power plant built in your lifetime a natural gas or coal burning power plant? Why aren't we doing more of this? If we have so many good choices, why do we keep making bad choices? Like me with food. I told my wife there's nothing in this house I want to eat. And she said, bro, we can't fit anything else in this house because we're just chock full of good food. And I'm like, I don't want to make good choices. I want like a fried hot dog with cheese and bacon. Wrapped in French fries on pizza. No jokes. Actually, seriously, because I have a slideshow and I want to see how many of you can generate these actual responses instead of me. Why don't we just do more sustainable energy today? Yeah.
It's not efficient enough for it to be bankable.
So the efficiencies question, you mean financially bankable?
Yeah.
There are some unfortunate financial consequences. I'd like to analyze that a little bit better. Like, why isn't this profitable? Like, if you can just make sunlight on your roof, why can't you make money on that? It's actually a real serious question, and we can answer that one today. Yeah.
A lot of like America's infrastructure and wealth is like dependent on fossil fuels, and making that switch would like put a lot of corporations out of business that are.
You know, you're right that powerful people want to stay in power and money and all that, but you know, like a good idea economically is always going to beat the bad ideas economically. Like we're so kind of a free-ish market sort of, and like if you come up with a better mousetrap, you can still get rich off it.
Well, then why aren't people getting rich out of this?
Because maybe it's not a better mousetrap. Why isn't it a better mousetrap?
You have too many people.
No, you know, you can run a lot of people on this. This is not a rhetorical question. I challenge you to explain this. This type of question has come up on the AP test quite a bit. Ready? Here comes a list. This is just tack it on to the end of your 3.4 or 6.4 if you're looking for a place for it. First of all of this new stuff is new, and new stuff is risky, and nobody likes risky. You know, energy infrastructure is like multi-gazillion dollar business, and nobody wants to gamble with their multi-gazillions of dollars. I mean, imagine if I walk into a boardroom with a bunch of investors and I'm like, okay, imagine I'm in a bathtub and I'm wearing all my clothes and I got this plastic cup. They'd be like, no, hold on a second. You can skip this part and just show us the numbers. And I'm like, well, no, but you see the air. And they'd be like, no. The numbers. How much money are we going to get back? And you can say that for coal and natural gas and petroleum because those are established and we know that. We can do market study on all that crap. We don't have a lot of market analysis on most of these. So there's always an obstacle in economics, which is the risky new idea. And a lot of these have especially risky risks. I'll get to that. I've got like 6 slides on this. So why is it so risky? Next slide. You know, you need a supply that you can crank up. There's a wacky thing about our grid that nobody understands. Our grid always has more electricity than people are using at all times. There's no storage on the grid. At any given time, our electricity grid has more electricity than people are using. Here's a crazy news flash that a lot of students can't visualize. If in a single split second, your neighborhood uses more electricity than is on the grid at that split second, everybody's power goes off. It's called a blackout. So everywhere on the grid, like if you use 100 units of electricity, I gotta make 110. And at the ends of the wire, that extra electricity has to be grounded at all times. Imagine I have a big stack of glasses and we're pouring in water at the top. And everybody comes over and goes, and starts like slurping water that's falling out of those glasses. There still has to be enough falling at all times at the end. You always have to have more than people are using. That's just how the grid works. Here's why that's a problem. Natural gas, coal, nuclear, petroleum power plants, if he plugs in a generator, I can just crank up how much I'm making at the power plant. If it looks like your neighborhood's going up to 110, I can just drive it up to 120. But these, the baby Jesus is in charge. What if you're all using 110 and all of a sudden there's a cloud? Or all of a sudden there's a break in the wind? Or, I don't know, the ocean has a flat spell. All of these, this is a good word for you to have in your notes. These are all surplus electricity. We can always add it onto the grid. It's like, hey, we can turn down the nuclear gas. It's pretty sunny in Santa Barbara. These are like bonus. It's like, oh, you don't have to water your lawn so much. It's raining. But none of them are up to you. You can't switch it on. You can't crank up the sunlight. So none of these replace fossil fuels. You still need as many fossil fuel power plants because sometimes the wind stops and sometimes it's shady and sometimes the ocean is calm. So the inability to control a lot of the renewables is a problem. I think someone mentioned that today. Here's another problem. Even if you got a lot of wind in North Dakota, I'm pretty far from North Dakota. And even if you got geothermal in the eastern Sierras, that's still a little too far for me. And if you got pretty good swell energy up in the northwest, that's still too far for me. Like here in Santa Barbara, I don't get most of these, and the rest of the United States doesn't get most of them either. But anybody can have coal, anybody can have natural gas. Abby Brumman with the cell phone. Yeah.
When we talked about like the power plants in relation to neighborhoods and houses, weren't you saying that like most of our power is coming from like distant power plants? So aren't we?
There's
already
distant and then there's really distant. Do you know where your closest natural gas power plant is? Okay, because it's outside your neighborhood, right? But it's up near Gaviota, just north of the Tahigas landfill. So that power plant is, you know, regional to you, but it's, you know, it's not like attached to your house. But the closest wind farm is further. The closest, what do you call it? Municipal solar is further. Like you can't bring Tehachapi electricity all the way here. Then there's this problem that nobody wants these things to block their view. Like, what if I said, yo, I'm going to do oscillating water columns right off Butterfly Beach, right in front of the Biltmore. Is that cool? Like, you think they're going to be okay with that? Like, where's the closest coastline that someone's not going to get pissed? Nowhere? Like, can you imagine a U.S. coastline that doesn't have stakeholders? Like, I'm not, that's not a rhetorical question. I really cannot imagine a U.S. coastline where the natives are going to be okay. People who live in Washington and Oregon and California and Texas, Louisiana, Mississippi, Alabama, Georgia, whatever. I don't really know those states. Florida and the Carolinas and the Virginias and stuff. Nobody's going to be okay with this.
I mean, they're already drilling there, so why would they?
Yeah, you know, maybe, yeah. They're drilling pretty far offshore in most of those places. You know, like in more than 1,000 feet of water. I'm not sure. Yeah, so maybe we got to push it out. But I mean to say that you'll always piss off someone. And if they were drilling right on the coast, you might piss off more people. Yeah?
Are we drilling like in the middle of the ocean somewhere? Like if there's like a really big, just off the coast?
It's too deep. Too far to get down to the bottom there. You know, fossil fuels, you can pick where you put it. It's like, oh, that canyon's pretty well hidden. But you can't pick where you hide a lot of these. Yeah?
Is it still too deep to do like offshore geothermal on the mid-ocean ridges?
I would assume so, but maybe near Iceland. And there's this thing called there is no such thing as a free lunch. Look, there is no such thing as a free lunch. Called Tinstoffel. Meaning that all of these have a problem. It's not like you could ever say that there's no problem. You could never say, I've got the solution, nobody's harmed. That's not a choice. So rare metals and who knows what's in those solar panels, and most of them produced in China now. We have a trade war with China, and so nobody's going to be happy with that. And then, like, the pilots don't like this. And they fry birds also. And the platinum is hard to get, and the economics of making hydrogen doesn't really work out, and hydrogen's explosive, and you can't ship it easily. And, like, the rivers are full of salmon, and we care about rivers and sediment flows and farmers and cultural value, and we'll talk about rivers later. And, you know, the wind and the bats and the birds and all the sensitive sea life and all the fishing grounds and all the coastal areas where people want to go frolic in the sand. And everybody has a stakeholder. Like, you'll never have an energy source that doesn't have a problem, so. Plus their land use. There's an interesting thing that many of these use a lot of acreage per kilowatt. Like, a lot of renewables are not concentrated. They use a lot of land. But I've got an idea for you. Wherever you are, if you got a growing city, or 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 you got a growing city, wherever you are, I can bring you some train tracks with coal for a coal burning power plant. We build them every day. Here's some plans. You want a size 4 or a size 7 or a size 9? No problem. We got the power plant ready to go. You want a natural gas power plant? We can probably find some natural gas near you. We can tuck it into a warehouse somewhere no one has to know. Fossil fuels has a proven track record with very little risk. It's a safe investment. There's a ton of supply. We know that there's no shortage of fossil fuels. It's dependable. You can turn it on whenever you want it. It's up to you. You want more, you just crank up the dial. Fossil fuels have a pretty small footprint. Don't worry about it. We get it from over there where those other people live. Fossil fuels wins. The simple, straightforward economics, like, it's a tough argument to make. Like, you want to try walk into a boardroom and try to sell them one of these technologies, and those guys all got another meeting in 15 minutes and they got to make a decision about how to invest $1 billion? Kind of a tough sell. You go through that list and imagine that you've got your favorite technology against the guy who's bringing in the natural gas power plant. You pick one. And you're like, oh no, I really want to do this thing. And I'm sitting in that same boardroom and I'm like, for natural gas, we give you a 20% return per year. It pays for itself in 8 years. We have 48,000 of these throughout the world. They never break. And it's like, your turn. Go ahead and sell that. Or like the dependability, like, oh, you just turn it up when you need more, no problem. Go try to sell your favorite one now. Or the transmission, like, oh, we can just put this wherever you want. How close do you want your power plant? You want it on the other side of the school fence? You can put it wherever you want. Or like, oh, you've got angry people on the coast, and you've got angry people on the ridgeline, and you've got angry people in the neighborhood, and you've got angry people complaining about the... No problem, we can put the power plant any place we want. Small footprint. All we got is these whiny liberals complaining about their fake global warming. Scammed by China. Oh, and by the way, we just use a little bit of land. It's a no-brainer. It's a no-brainer. Fossil fuels always wins. Anybody know the one thing that would change this forever? The one detail that hasn't come up in this conversation that's so obvious that you know I'm just talking around it, but what's the one problem with fossil fuels that's hard to beat? Yeah?
They run out. We don't have unlimited.
We do have a lot. So you're right that somewhere down the road we're going to run out of fossil fuels, but man, not in your lifetime, bro. What's the even bigger problem? It's a problem for you right now. Yeah, the CO2. Can you guys imagine if we started charging for CO2 emissions? Because you realize we're going to have to pay for the CO2 problems, right? I mean, your generation's going to have to pay for those. I always got mad when people would talk about climate change as a problem for the future. You all know that I'm a whiny liberal. My favorite president always talked about our grandchildren. When Barack Obama would talk about climate change, he'd always say, we have to do this for our grandchildren. And I was like, bro, you just have to do this for us. Like, it's already, like, that stuff is real. Thank you. I'm our counselor immediately. I've got a piece of this conversation that fossil fuels can't be, which is this climate thing. We gotta start paying for stuff now. You all realize that unusual storms are becoming more usual, right? Everybody knows that that's a thing, right? Like globally, rare climate events are becoming much more common. You realize that? It's not a newsflash to anybody, right? The unusual is becoming more usual around the planet. 100-year storms keep happening every year, so to speak. You know that the intensity of hurricanes is going up, not the overall number, but the global intensity of hurricanes. Also true for typhoons and monsoons in the Asian and Indian Oceans. We know that sea level is rising already. And so sometimes when there's a storm and it happens to be high tide and that tide happens to be higher than usual now, like, you know, we're getting real problems from rising sea levels now. Our ability to grow food is being affected. Our supply of fresh water is being affected. So we're going to have to pay for all that CO2, and that's going to get really expensive right around the time that you hit the economy. Like, pretty much you're going to live in an economy who has bigger and bigger wedges being cut out to deal with climate. My generation never had to pay for CO2. My grandparents and your parents, everybody before you got rich and they had a credit card. It's like, oh, you want to grow your economy? Here's a credit card. You can have all the fossil fuel energy you want. We're just going to send the CO2 cost to the future. It's like, can you imagine if somebody gave me a credit card and the bill went to your house? I would buy everything on that credit card. I'd be like, new boat, trip to Mexico, all your fishing gear, pay off the house, get a cool car, give me some liposuction. I mean, the bill's going to your house, see if I care. That's our CO2 economy today. Our fossil fuel world got built with one of the costs never a part of the equation. We just, you guys, your kids will deal with it. I love that. Everybody older than you has been thriving on that. All the energy billionaires never had to pay for the CO2. All those billions, you're like, wait, that's my bill, now I gotta pay for your billions? And they're all like, yep, that's how it works. You pay for it. So I don't know, I think sooner or later people are gonna be afraid of paying for the CO2. I think sooner or later we're gonna have to pay for that. And when that starts to happen, people will be like, oh, you know, I can take some risks and I can give up some of my coastlines and I can follow the Iceland example and I can start to reroute all of my trash. I think we'll find more places where we can do these. I think more houses are going to have these. I think we might need to give up some places so that we can run some of those. All right. Anybody want to talk more renewables? Well, is 6.5 the nuclear stuff? Oh yeah.
I was talking about 6.4 vocab. It says heads up vocab in SGs.
Study goals. So like a lot of words came up that were underlined along the way. Was 6.5 the nuclear stuff? Please take out 6.5. Sorry, I gotta check my notes on something. Here we go. Students, almost every word in 6.5 will come up in study goals. So I'd like to skip them for now. And I need to see by a show of hands, how many of you have had chemistry? Okay, that's lovely. If I put this on the board, can you give me the scientific, the elemental symbol for tin, please?
Look it up.
Yes. I think Claire's on it.
SM.
Thank you. If I put that on the board, how many of you know what I just did? Who could narrate this process for me? Uranium-235.
Let's fire a neutron at it.
Fire a neutron at it is going to make
236.
236. What does that mean?
Radioactive unstable.
It's radioactive and unstable. And so that's going to give us molybdenum, tin, plus, and neutrons. Raise your hand if you'd like a little support to understand what's on the board there. I'm going to start with a little chemistry band-aid. This will apply to all of you. Chemistry band-aid. This is a simple atom. It has 4 neutrons, 4 protons, and 4 electrons. That makes it beryllium. In case you didn't know, you're going to have to write some stuff down. The element is decided by how many protons. That's a fact that you all have to know. And if you've had chemistry, you've probably heard that before. So hydrogen is number 1 because it has 1. And helium is number 2 because it has 2 protons. And lithium is number 3 because it has 3 protons. And beryllium is number 4 because it has 4 protons, and so on. Neutrons and protons are in this thing called the nucleus. Gravity keeps them close together. They have a lot of mass. Told you that thing always does that. Hate that thing. Scared you, right?
Yeah.
Dude, I have screamed in his class. Trying to be all serious with some student, I'm like busting, all of a sudden he goes, and I'm just like freak out. Horrible. Most see, making my time. We'll continue with the chemistry band tomorrow to start nuclear. Bye-bye.